Okay, we'll continue on here with our subsetting. We'll wrap that up with some applications of subsetting, and then we'll get started into flow control. And last class we only got through if statements, so we didn't get too far, but we'll do our best, okay? All right, so I think we left off last week talking about matching to a data frame, okay? So before this we said, you could create a lookup table with a named vector. We could say, you could just have a named vector. Maybe that named vector only has 2 or 3 entries in it, and the actual vector that you're trying to kind of match values to is much longer. But because R allows you to repeat indices in the subsetting, you just subset the short named vector, which only has maybe 3 entries in it, but you subset it to the long thing, and it will just continue to repeat those values. Okay? Likewise, we can do the same thing. Here we have a small lookup table. It's a data frame with 3 rows, okay? The columns, first the row names would be 1, 2, 3, and then the columns for grade go 3, 2, 1, and the description goes excellent, good, poor, and then the column for fail is going to be false, false, and true. And these are the grades we're going to enter: 1, 2, 2, 3, and 1. So this was the failing, good, good, excellent, and failing, right? Or poor. So we're going to look this up. The way we're going to look it up is by using the match function. The match function takes an input vector, in this case grades, and it's going to say, okay, which of these match, what is the row that matches this column info $ grade, okay? So let me kind of, maybe it'll be easier to, I think it's okay. So basically this says, when you run the match here, it's going to look up this value 1, and in our lookup table, which row has grade equal to 1? That's the 3rd row, okay? Over here it finds the 2, and it says, in our lookup table, which row has grade equal to 2? The 2nd row, okay? Over here it gets to this value 3, and it says, which row in the lookup table has grade equal to 3? And that's the 1st row, okay? So, I mean, in this case, because it goes 1, 2, 3, and 3, 2, 1, it just kind of mixes them up. But if you had things like A, B, C, D, F, and things were just in different order, it would say, which row matches this value that I'm providing it. And so we will then subset based on this, and we're going to just subset info using 3, 2, 2, 1, 3. We're going to say I want row 3, 2, 2, 1, and 3, and it returns that. It says, okay, it's going to give us the 3, row 3, then it gives us row 2, and then it asks for row 2 again. R does not complain. It's happy to return the same row more than once, but to kind of distinguish the names, the row names from each other, to distinguish that this is the 2nd time you're calling row 2, it appends a .1. Okay, so we've got a 2, and the row name is 2.1. The content is exactly the same, it's just the row name changes to 2.1. Okay, and likewise, it would pull up row 1, and then this row, the 2nd time I'm calling 3, is going to pull up 3.1 for the name. Okay, and that's what we see. Okay. So if you have multiple columns you want to match with, you can first you need to first collapse them to a single column. So that's one thing you can do. Okay, we can also use R's built-in function sample to create random samples. And and you've probably had to create random samples before, but this is just a quick way to do it using subsetting. Okay, so here I'm creating a data frame. This data frame df has 6 rows in it. Okay, column X goes 1, 2, 3, 1, 2. I'm sorry, column X goes 1, 1, 2, 2, 3, 3. And then column Y goes 6, 5, 4, 3, 2, 1. And column Z goes A, B, C, D, E, F. We're going to use a set seed to so that our randomization process can kind of be traced, right? You can always call the random process and it will produce random values. But if you ever want to give your code to someone else and say, hey, look at what I've got, it's a good idea to set your seed, okay? Because the values, when you ask for a random value from the computer, it acts like random numbers, but they're not truly random. They're pseudo-random, and they're defined. They're kind of this predefined trail of numbers, and you can kind of select your starting spot using set.seed. Okay, you can read all about the random numbers. It's quite complex, but yeah, setting the seed defines a certain starting point, and so if I set the seed 10 and you set the seed 10 and we both call the same random function, we're going to both get the exact same results. Okay, which means it's not truly random, right? But they certainly act like random numbers. Okay, anyway, here I'm saying sample n row df. Okay, n row df says how many rows are in the data frame? 6. So effectively, this is just sample 6. And when you say sample 6, the default behavior of sample is to take the integers 1 through 6 and just shuffle them up. Okay, so in this case, when I said sample 6, it took the integers 1 through 6 and it shuffled them up and it returns 4, 2, 5, 3, 1, 6. Okay, and then by subsetting df on sample 6 or sample n row df, it returns our data frame shuffled up. Okay, so originally it went A, B, C, D, E, F, but now after we subset based on this sample, it has shuffled everything up. Okay, we can also subset, just create a sample drawn from a larger thing. So if you've got a large data frame and you only want to select a few rows, you can just say sample n row df, comma, how many rows you want. Okay, so here we're basically saying sample from the values 1 through 6. I only want 3 random numbers. Okay, and so from here, we're pulling 3 random numbers, and we're going to select rows 2, row 6, and row 3. Okay, and obviously this would work if we had 1,000 rows and you wanted to select a random sample of 50. Okay, the default behavior of sample is that it will not select the same number more than once. So if you do sample 100, it's going to take all values 100. It's going to shuffle those up and not select the same number more than once. If you have replace equals true, it will sample with replacement, meaning you can draw the same value more than once, and other values may not be drawn ever. Okay, and that's very useful when we perform bootstrap, and that will come later on in the course. Have you guys heard of bootstrap or done bootstrap? Okay, maybe. All right. We can use the function order. Okay, order takes a vector as its input, and then what it returns is the indices that you would use if you wanted to put this vector into order. Okay, so it's not a ranking, it's the ordering. Okay, so here I've got the vector goes BCA, and if we want to put this into order, then the first thing that I would use would be the third element, which would be A. Then I would pull the first element, which is B, and then I would pull the second element, which is C. That's what this means, 3, 1, 2. And so if I subset X based on the order, then it will be put into order A, B, and C. Okay. There's a few options for order. There's decrease equals true if you wanted to put them in reverse order. If you wanted to, by default, the missing values are put at the end. If you want them removed, you say na.last is set to na, or if you want them in the beginning, you say na.last is equal to false. Those are some options for ordering. Okay. If you can use order to rearrange a data frame. Okay, so here if you recall, the original data frame df was 112233, 654321, and A, B, C, D, E, F. Okay, and here I'm using sample to just rearrange the rows, and I'm rearranging the columns. Okay, so df2 has the columns mixed up, or columns reversed, and the rows all mixed up. When I run order, I'm going to say order based on column X. Okay, when I order based on column X, it's going to put X into order from least to greatest, 1, 1, 2, 2, 3, 3. So it has arranged that. But because I only specified X, it does not care about the other columns. And so you coincidentally, it went A, B, C, D up here, but E and F did not get put in order because it doesn't look at column Z at all. So it's not trying to put column F in order. So here it's just putting column X in order, and it doesn't care which of these threes came first. But this is what it did. Okay. If I wanted to rearrange the columns, then I can just do order the names of df2, and it arranges them into alphabetical order. Okay, this is a useful application. It says expanding aggregated counts. Sometimes you'll get a table, okay, and the table summarizes your data into a frequency table. Okay, so rather than having kind of one observation per row, it has already summarized everything up, and it says you had, this observation 10 times and this category 7 times or something like that. And perhaps for your analysis, you want it expanded back out. Okay, how can we do that? Okay, one way is to use the function repeat and then use the subsetting function. Okay, because again, one of the most useful things about R is that you can repeat indices when you subset, and it will repeat the same row or that same item multiple times. So here, this is worth a little exploration here. Okay, so here I'm going to create this data frame here. So here I just have numeric data, but it could be categorical data. It doesn't matter. Okay, so here it says the value X had the value 2 and Y had the value 9, and the frequency is that this showed up 3 times. Okay, and then this data point, whatever it was, it showed up 5 times, and this data point showed up 1 time. So what I can do is I'm going to say repeat the row names 1 through, in this case, n row df is just going to be 3. So my data frame only has 3 rows in it, so I'm going to say repeat 1 through 3, but how often do I repeat them? I repeat them based on this column 351. Okay, and so when I do that, it's going to repeat 1 3 times, it's going to repeat 2 5 times, and it's going to repeat 3 once. So I get 1 1 1, 2 2 2, 2 2, and 3. Okay, and then now if I subset df based on this entry, repeat 1 through n row df, comma df $n, okay, comma, okay, because it says I want the rows corresponding to 1 1 1, 2 2 2 2 2 2, and 3, then it repeats that. Okay, and so it repeats all of these rows. So it has repeated x and y 3 times. It repeated this entry 5 times, and it repeated this entry 1 time. Okay, so this is very helpful. And then after you've produced this, you want to get rid of the row names, or you want to change the row names, you can do that. You want to get rid of this column n, now that it has served its purpose, you can do that. But you can quickly kind of expand the counts in a summary table this way by taking advantage of R's obedience in repeating subsets. When you subset based on repeated indices, it's going to repeat the thing. All right, and then if you want to remove columns from a data frame, there's a few ways we can do it. You can just take that column and null it out, okay, and that will kill that column entirely. Okay, that column just disappears. Or you can subset and just ask for the columns that you want, or tell it the columns that you don't want, or something like that. And so in this case, we're gonna df itself is unchanged, and this subsets the data frame df, saying I only want columns x and y. And if we want to store this somewhere else, say data frame 2, we could do that. Okay. Obviously, if we store this back into df, then the information we didn't keep is lost. But you can, create a copy of this and store it somewhere else. Okay. Whereas this df $z and then overriding it with null kills that thing in the original data frame. Okay. We have some set functions. If you know the columns you don't want, you can use set functions. In this case, set diff is the values over here that are different from the values provided over here. Here I just gave it one value z, but you could give it a set of values. You could give it x and z, and it would just keep the values over here that are different from over here. So it's these are set functions. All right. On the other hand, we can subset based on row conditions. Okay, and so everything here we're putting before the comma, and I think we're familiar with this one. We can use a logical vector. In this case, empty cars $gear equal 5. This is going to be true when the column gear is equal to 5, false for every other false for every other row, and so only those rows where it's true get selected in the subset. We can then combine logical statements using ands or ors. Okay, and so in this case it says the column gear has to equal 5 and the column cylinder has to equal 4. Okay, and select only the rows where both of these are true because of the and symbol. Okay, and so in this case there's only 2 rows where that's true, and that's these two vehicles. Okay. If you wanted to do an or, you can use the or operator. And in any of these cases, we only use the single and or the single or. Okay, those are the vectorized and ors. If you have the double and or the double or, these are non-vectorized, and we use these for if statements. They only will return one true or false value, not a vector. So these ones will do you give it a vector of true falses. These ones will not allow that. Okay. And then you have the negation operator. This is not whatever this is. Okay. And then okay. And then you get your De Morgan's laws from set theory and stuff to help you out if you forget. There is a function called subset, which saves you a few keystrokes if you want. Okay, so rather than having to say empty cars square bracket empty cars gear equal to 5, you can just say I want to subset empty cars where gear is equal to 5. Okay, and the subset function recognizes you're talking about column names here. Okay, and so that's a little bit of a shortcut to save you a few keystrokes. Later on, we will cover the package dplyr, and I find dplyr to be even easier than using some of these subsetting functions that R provides, and so we'll cover that in the coming weeks. But for now, you can use subset or square brackets, and they all work. Okay. It's worth talking a little bit about Boolean algebra versus sets. Okay, so Boolean algebra, this is all for the logicals, the trues and the falses. Okay, but we also have set operators where you say these things are in a set and these things are not, are in a different set, and I either want the intersection or the union. And there's kind of a parallel idea between the logical ands and ors, and then the ideas of intersections and unions. Okay. Probably most of the time we will end up doing the logical, the Boolean algebra, but with the ands and the ors. But sometimes set operators are effective as well. Okay. So which converts from a Boolean to an integer representation. Okay. So in this case, I'm going to take, I'm going to sample the values 1 through 10 and shuffle them up. And then I'm going to just turn them into trues and falses by saying which of those values ended up less than 4. And when I did this, this value was true, this value is true, and then the last value is true. Okay? So there's only 3 values that are smaller than 4, 1, 2, and 3. And I don't know exactly where they ended up, but after the shuffling process, they ended up here in spot 2, spot 3, and spot 10. Okay? The values 1, 2, 3 somehow shuffled up in there. So we've got this logical vector of trues and falses, and then which will tell me which of these ones are true. Okay? And so this is often helpful when you know, you've got some kind of data frame or something and you want to know which row is the one where some condition is true. You can always say which, you put in your logical condition, which is going to be, you know, trues and falses, and which will tell you, you know, which rows or which indices correspond to trues. Okay, so we're going to create a few vectors here, okay? x1, the vectors that end in 1 are logical. The vectors that end in 2 are integer, okay, or numeric. So x1, we have 1 through 10 modulo 2 equal to 0. Okay, so this is basically going to be true if it's even, right? So the first one is false, then we have true, 3 is false, 4 is true, so on. So it goes false, true, false, true, false, true. Okay, so x1 is that logical vector. x2, we apply the which to that, and so it says 2, 4, 6, 8, 10. Okay, so it tells us that that the values where this thing was true were 2, 4, 6, 8, 10, which makes sense to us, right? And then we do the same thing with y. Y is which ones are divisible by 5, and so it's false for everything. It's true for the 5th one, and it's true for the 10th one, and it's false everywhere else. If we ask which, it tells me 5 and 10. All right, so we'll see the parallels between the logical operators and the set operators. Okay, so here I've got the and between x and y. Okay, this is only going to be true when both x and y are true. So x is true for all the even ones, y is true for all the values divisible by 5. And so we get false for everything except for 10, right? So we're just saying and between this thing of falses and trues and this thing of falses and trues. So both of them have to be true to return true, and we only get true on both for the 10th value. Okay? Or we could just say intersect x2 and y2. What's the intersection between 2, 4, 6, 8, 10 and 5 and 10? The intersection there is 10. Okay? So you apply intersection for as the set operator, the Boolean algebra is over here. Okay? On the other hand, the or acts kind of like a union. Okay? So here we have or will return true if either one is true or both are true. Okay? And so we get true for all the even values, we get true for the 5, and that's what we have. And then if we ask what's the union between 2, 4, 6, 8, 10 and 5 and 10, it says we got 2, 4, 6, 8, 10 and 5. Okay? So that's what the union will return. Okay? Over here we've got x1 and not y1, right? So this is the part of the, if you're thinking of your Venn diagram, right? You've got your Venn diagram. This is the part that is it kind of looks like the crescent moon, like a crescent moon. It's the part that is in X, but it does not overlap with Y. Okay, and so in this case, that's the set diff X in X but not Y. Okay, and so this is what we have for the falses and trues, or you can do set diff, and so it says 2, 4, 6, and 8, but because 10 overlaps with Y, it's not included. Right. And then exclusive OR, if you're thinking of the Venn diagram, it's basically the two crescent moons without that middle piece. Okay, so it's what is in one and not the other, and it cannot be in both. So exclusive OR is it has to be yeah. So we can do XOR X1 and Y1, so we get false, true, true, true. Okay, so this means so we would get 2, 4, 6, 8, and 5. So it's in one or the other, but not both. Okay, and we can think of this as the difference between the union of everything without the intersection. Okay, so that's one way to think of it. Or you could do union of this crescent moon and the other crescent moon is another way to do it. Okay, so that's these are kind of our the parallels there. All right, are there any questions on any of this, right? And then so, you know, if you have trouble thinking of, my brain has an easier time with the logical Boolean things, okay? So, you know, if you have to do this but you're having trouble with this, you can always do the logical ones and then do which, okay? And that's effectively the same thing, right? But if one way works or another, you can do it this way, right? Okay. Yeah, all right, so this is just a comment. It says, you know, when learning subsetting, a common mistake is to use X on which instead of X just on Y, okay? The which achieves nothing. It switches from logical to integer, and the result will be exactly the same, okay? Okay, now we can talk about some basic programming stuff, okay? And so that wraps up our discussion on subsetting, and so we'll start talking about some basic programming. Okay, so first things first, make sure you have your working directory properly set, okay? I recommend, you know, for your homework assignments to create a directory for each homework assignment, okay? You're gonna get like 6 homework assignments or whatever in this class. Just create a directory for each one. The first one, there wasn't a whole lot of things to do, so it's fine if you didn't. But I would say for the future ones, create a directory for homework 2, a directory for homework 3, and then put the file in there. Because our defaults to wherever you open up your file, it generally defaults to setting that thing as your working directory, okay? So, so from, you know, don't just download your file from CCLE and then open it, because then the downloads folder will be your working directory, and then your downloads folder is probably crazy, right? So just move the stuff, move that file to a, you know, a directory that you've created for your homework and work there. Okay, you can always check what your working directory is by doing get wd. You can also go through the menu, okay, and you go to session and you do set working directory, and you can do all of this stuff. But generally, if you save your file to a certain directory and you open it from there, then R will default to that. But you can always, and it's very quick, and if it didn't for whatever reason do that, you can always do set working directory to source file location, right? Okay, if you're on a Windows machine, you gotta use either use double backslashes or forward slashes to type if you're gonna type out your working directory, okay? You would type out your working directory in case you're like writing a script, okay? You're writing a script and then you kind of want, I don't know, you've got some directory that you've specified and you always want to set that working directory within your script itself. You know, that's an option, but okay. Comment, I think you guys know how to comment your code. You use the, whatever this thing you call it, the hash mark, or it used to be like the pound sign, I don't know. whatever we call it. Okay, and in RStudio, there's a shortcut. You can always highlight your code and then hit Control-Shift-C or Command-Shift-C. Okay, and that kind of toggles whether it's a comment or not, which is very useful if you're like, trying some code out, but maybe you want to turn it off for a second. You can kind of like highlight a chunk of code, just comment it out, and then come back. What's going on here? You know, you can come back and toggle it on and off that way. Okay. And it's always a good idea to write more than enough comments, okay, as notes for yourself, okay? Because generally, you know, they say your most important collaborator is yourself from 2 months ago, but that person doesn't return your emails. So, you know, if you don't know, if you had to do a little bit of acrobatics to come up with a certain line of code, right? And you're proud of this thing, it's a good idea to write a comment. Just say like what you were thinking when you wrote that code, because when you look at it in a couple months, you might not remember what you were thinking. You're like, how did I come up with this thing? Okay. I also recommend clearing your workspace every time you get started, okay? And perhaps even under global options, just in general, I always say save workspace to our data on exit to never, okay? So this will keep you out of the habit of leaving stuff in your workspace and expecting things to be in existence when you load up a new session of R. Okay, so and I always so you can clear out your workspace just by hitting the little broom, and it deletes everything. Or you can type in rm remove everything list equals ls. Okay, and when you do that, because ls lists off everything that exists in your global environment, and if you remove everything that's named in the global environment, and removes everything, and then if you ask to list everything, it's going to say I have nothing. Character 0, right? That means character vector of length 0. There's nothing in your global environment. Okay. I also strongly recommend for any kind of lengthier coding project to write things as an R script. Okay. Rather, I know I post my homework assignments as RMD files, and it's tempting to just write everything in the RMD file, okay? If it's a smaller assignment, smaller scripts, sure, that's fine. But if you have anything longer than that, you know, open a new script, okay? And then write your code here, because if you're expecting R to run your stuff, okay, you can keep clicking this play button, but you got to run a lot of overhead, and then if you just want to try something out, you know, and you click knit, R has to do a lot of thinking just for the markdown portion, right? It's got to figure out how to lay out the stuff on the page, and you don't really know exactly what's happening, because when you run it, it shows you stuff like for each code chunk, you just get ... You know, I ran this to 100% or something like that. So it's not very informative. So generally, any lengthier script right over here, when you get it working, then you can copy it over to your markdown file. Okay, nobody gets it right on the first time, so it makes sense to just have a spot where it's very responsive. Okay, and then on the other hand, you shouldn't just program directly into the console unless it's, again, just a quick one-liner, and you just need to kind of check what the value is of something. Okay. Otherwise, you know, in general, everything you write in your console, you know, doesn't really get saved. You can always access them in history, and then you can say like, oh yeah, I want this, and I want to save this, and move this back over to the source. You can do that. I mean, RStudio has nice little features like that, but generally, write them up here, Command Enter, Control Enter to run it. Okay. All right. Let's talk conditionals now. Okay. And yeah, we'll probably get to the same spot we got in the last class. All right, we've talked about these already. We've got the or and the and, okay, and then the not. And these are vectorized. The single or, the single and the not, those are vectorized, so you can give them vectors of logical values and it will work. The double or, the double and, those are not vectorized. You can only give it one value, okay? And then the exclusive or is vectorized, and then is true is, we don't use it very often, but that one's not. Okay, so we've got and, the bars mean or. Vectorize will do element-wise comparisons as well as recycling. The non-vector, the double and or the double or, is for if clauses, okay? And then we've got the not indicator there, okay? If you give it numeric values, those will be coerced into true and false values, okay? So generally, a lot of times, true and false values get coerced into integer values, but these operators will coerce numeric values into true false values, where only 0 gets coerced into false. Everything else, 0.1, -2, those all get coerced into true. Okay, so here x is true, true, false, false. Y is false, true, false, true. All right, so the single or operator will return true if either or both are true. So we got this is true here, it's false when both are false, and it's true everywhere else. The double or only looks at the first elements, this true and this false, and it returns true. It only looks at the first one. The single and will return true only if both are true. So true, false is false, true, true is true, and false, false, and false, true, those are both false. The double and only looks at the first elements, true, false, and it returns false there. Okay, so it only looks at the first element. Exclusive or is will return true if one is true and the other is false. Okay, but if both are true, it's exclusive or will return false, and if both are false, exclusive or will return false. So if we look at it here, we've got x and y. Exclusive or is vectorized, so it gives me true for this case, but when both are true, it's false. When both are false, it's still false, but if one is true and the other is false, it's going to return true. Okay, is true is kind of a weird thing to just see if x is identical to the true object. Okay, so it has to be a length 1 logical vector whose only element is true and it has no attributes, okay, which is, I don't really use this function very often, but it does exist. So when we ask, is x true, because there's 4 elements in it, it's false, okay, because it has to be a length 1 logical vector. And if it had names, it would also be false, right? Okay, when you got numbers, vectors of numbers, you can do comparisons, and all of these things are vectorized, so less than, greater than, equal to, not equal to, all of those. And then you have the in operator, which is very useful. You have, is some element x in another vector y, okay? And if it is, it's going to return true or false. And that's also vectorized for the items in x. Okay, so we can throw all of these true-false results into an if statement, okay? But an if statement will only accept a single logical value, okay? You can't give it a vector of logical values. You have to give it just a single one, and that's why we prefer the double and or the double or for if statements, okay? And then how the if statement works is that if that condition is true, then the associated code will be executed. Okay, and you associate the code by using curly braces, or if there's only one line of code, the following line is associated with the if statement. Okay, but if you got multiple lines, you use the curly braces. Okay, so here I've got x is 1 and 3, and we ask, is 1 in x? And that's true. Okay, 1 is in x. Okay, so I say if if 1 is an x, which is true, print hello. Okay, this thing evaluates to true, so it prints out the word hello. Okay, it executes this code which is associated with this if statement. Okay, if I had multiple lines, I would have a curly brace. Over here, I have x is 1 and 3, and I say, is x greater than or equal to 2? Okay, this is a logical vector. It says false and true. Okay, if I feed this logical vector into an if statement, okay, the if statement only looks at the first value, and it says, wait a second, you gave me a logical vector that's more than one, has more than one element in it. So it kicks back a warning. Okay, so it says, warning, you gave me 2 logical values, so only the first element will be used. So it says, okay, I'm only going to look at the false, and so it says if this thing evaluates to false, so because it evaluated to false, it doesn't bother executing this code. So this code is not run at all, and that's why you don't see hello again printed anywhere here. Okay, it just kicks back a warning and says, you gave me a logical vector too long, I'm not going to do anything. Okay, so we can fix that by using any, or there's a whole bunch of other things we could have done. If you wanted to cycle through these the values false and true, you could run a loop and say run it for the first bit of the first element and then run it again for the second element. Any is like the mega or. Okay, so or you just give it 2 logical values, and if one of them is true, it will return true. With any, you can give it a vector, of 100 logical values, and if any one of those is true, then any will return true. Okay, and any will return false only if the entire vector is false. Okay, so in this case, we say, are any of these values greater than 2? Yes. So if that's true, print this out. This is true, evaluates to true, so the following code is executed, and it says, can you hear me now? Okay. Yeah, I guess I talk at the same speed in both classes, so this is where we ended up in my other class, and so we'll end here, and then so on Wednesday we'll pick up right here on nesting conditionals with else's. Okay, so we'll see you guys on Wednesday. I'll probably post a homework either tonight or tomorrow, probably tomorrow. That will be due sometime during week 3, okay?